Hi, my name is Hava Schuster, and today we are discussing the difference between incomplete dominance and codominance. First things first, to understand what we are actually talking about, I need to cover Mendelian genetics. Alleles are variations of a gene, and your genes are what encode your genotype, which is what you have, and these genes in your genotype will correspond to your physical characteristics in your phenotype. So in Mendelian genetics, it states that you can have two dominant alleles and be homozygous dominant, or you can have two recessive alleles and be homozygous recessive. Yet, if you have one dominant and one recessive, you're always going to have the dominant phenotype. But that's not what we're looking at today. Specifically, we're looking at what happens when you have a dominant allele and you have another dominant allele of the same gene. Some traits in reality are actually expressed both as dominant. And when these two different kinds of dominant alleles are present, they will show up differently in the phenotype. In incomplete dominance, it states that both of these alleles are dominant, except they don't have complete dominance over each other, and they show up as an in-between between both of the alleles / traits. A good example of this is in flowers. Specifically with roses, roses have a gene that corresponds to their petal color. One might be red and the other might be white. But if both of them are present, they're going to have pink flowers. If you're still having issues thinking about this, just imagine you're making chocolate milk. That's how I remember it. You have the milk and you have the chocolate. When you mix it together, they're not. It's chocolate milk, and the chocolate milk appears light brown. It's not brown like the chocolate was, and it's not white like the milk was. It's light brown. Yet this is different in codominance. Unlike incomplete dominance, in codominance, both of the traits are dominant over each other. And so, what they will appear like is a molted or spotted version of whatever gene it was. So you can find codominance in flowers and animals, and it's all over the place. In cats, the gene that encodes for their coat color is found on their X chromosome. So for the most part, most cats, especially males, don't have to worry about having more than one color. But if you're a female cat, you can either have two genes that encode for black, or you can have two genes that encode for orange, or you can have one that codes for black and one that codes for orange. Both of them are dominant, and it's going to be expressed. That's how you get tortoiseshell cats. If this is still confusing to you, you can use the example of beans. Like, if I take red beans and pinto beans and mix them together, it's all beans, but you can clearly see the difference between the red beans and the pinto beans. And that's how it's expressed in animals and plants. Now, I'm very passionate about genetics as a whole. And for right now, this is where we are stopping. Bye!